Well, good afternoon. My goal with this problem is to do a quick review of how to calculate least squares regression lines and how to interpret and evaluate their effectiveness. This data set that I'm going to be using is a selected number of states, about 8 states, and their per capita revenue versus their per capita expenditures. So first you need to make sure that you have these states in your calculator and that you have entered the numbers correctly. The first step is to make a scatter plot. So to do that, you will want to choose the stat plot and put in the revenue. Choose the scatter plot icon, put in the revenue versus the expenditure data, and clear out any y equals signs you might have. Hit zoom 9, and that is in fact the scatter plot we're looking for. You'll want to bring that scatter plot over to your worksheet and make sure you put the title on and label the axes with their numbers as well as with their titles. And to find out what window you would like to choose, you can press the window button and bring those numbers over as well. And we have those placed right there for you. All right, first thing is to interpret the scatter plot. And this scatter plot appears to have quite a strong positive linear association between the state revenue and the state expenses. And that is seen because there are no curving and most of the dots are pretty close to the regression line, even though technically that should not be in our picture yet. The next step, we are going to have to do stat calculate 8. So quitting out of the window, we do stat calculate 8, and we're going to do it on the revenue, comma, the expenses, and then I'm going to use my secretary to put it into vars, y-vars, enter, enter, and all of that information is what I'm going to need next. I've already transferred that over to our screen. The R value is 0.93. This does verify what my eyeballs saw, which was a strong positive linear association between state revenue and state expenditures. Using more information on this screen, I am going to calculate the least squares regression line, which in this case will be y equals 314.79 and a slope of 0.905x. Please remember to put your hat on the y values. To interpret the intercept, that is the number that is all by itself right here, 314. That basically means that if a state were to make no money, then its expenditures per person would be predicted to be $0.905. So if the state brings in nothing, it would still be basically spending $1 per person. The slope, what does that mean? Is the state revenue increases by $1, the state expenses are predicted to increase by $0.905. Please make sure you're using these words predicted. That is something that I did not remember to emphasize in class. So these are predicted values because this is the least squares regression line. Next step is to pick a point and plug it in. I used $6,000 and I got out $5,744.79 per person. I know this is extrapolation because when I look back at my original data set, and if I look at the x values here, 6,000 is higher than each of those x values. So that is how I make the determination that it is extrapolation because it is much higher and is outside the domain of my data. All right. Is it feasible? I said I thought it would be feasible. In fact, probably due to inflation, if these are old data values, that must already be happening somewhere in a state. Okay, interpreting R squared. R squared is 0.87. That means 87% of the variation in state expenditures per person can be explained by the variation in state revenue dollars as calculated by the least squares regression line of the expenditures on the revenue. S, if I use my calculator to do stat, tests, all the way down to the bottom, Lin-Reg t-test, and if I put in revenue and expenditures, plug my equation into Y1 and hit calculate, that calculates my S value for me right here on the screen, and I've transferred that over to our paper already right here. The S value is $319.95. It is the standard deviation of the residuals. This is the typical amount the observed state expenditure differs from the predicted state expenditure, and that is on the least squares regression line. The next thing we have to do is take a look at the residual plot. To find the residual plot, I use my calculator, hit second Y equals, turn plot 1, make sure it's back on, but instead of graphing the revenue versus the expenses, I'm going to graph the revenue versus the residuals, which were calculated already for me by the little lady who lives inside my calculator and is my secretary. I can turn my Y equals off temporarily so I don't see that, and then choose Zoom 9. That's the scatter plot I have over here on the worksheet for us. Please be sure again to label and also put your window for this in. Again, the window can be found by hitting the window button and then just moving those numbers on to your paper. The Y minimum is $358, not $3,000. That makes me feel a little bit better about the size of these residuals. And then the x-axis is still the state revenue, but the y-axis is not the state expenses anymore. These are the residual values that I calculated when I did least squares regression. Okay, we can see that there doesn't appear to be any curving here. That's a good thing. So the residual plot reveals a scattered pattern, so the linear model can be used. It's appropriate. However, the residuals are not small. They're pretty large. But if you go back and compare them to the Y values that are way back at the beginning of the worksheet, these Y values range from the lowest being 3,027 to the highest being 5,500 almost. That's a range of about 200 or 2,500, 2,500. So while these residuals on this page are not small, they're also not terribly large compared to a scale of 2,500 when we're going less than 1,000 here. Next, I ask you to examine the effects of this data point. I believe on your sheet that you got in class, I did ask you to take out Texas, a very famous state where, according to George Strait, all my exes live in Texas. So if I remember my original data with the Texas point, here are my values. And when I take the Texas point out, and I can do so by turning my stat editor on and going in and taking out the values for Texas in both the X and the Y lists. And then I can do second entry, bring back my Lin-Reg, recalculate that, and that is how I get my new values over here. I did this one with the stat test, And we see that we, in fact, have a very different y-intercept. The slope did not decrease that much. The r values, we used to have an r squared of 80.87, and now it's down to 7.5. And r itself has decreased a little bit, but not drastically so. It has decreased some, but not terribly a whole lot. So I say this point seems to affect the y-intercept the most. The r squared and r values are changed, but not too much. It just barely weakens the association. So I call it an influential. Texas is influential because it influences the y-intercept quite a bit. Now my final conclusions. In my final conclusion, I want to know, should I use a line and how good is it? So I say I would use the line with a tiny bit of caution. The scatter plot and residual plots are pretty solid, and the correlation coefficient is very strong. R value is strong, so it can be used for interpretation pretty strong, pretty effectively. It does imply that there's a relationship. The most influential point is Texas, but when you take Texas out, it doesn't really affect the relationship a terrible amount. It just changes our beginning y-intercept. So that means it's influential, but doesn't affect relationship very much. I would use this model to predict state spending, the state spending associations between expenditure or revenue and expenditures, and only apply a small bit of caution.